What a beautiful day it is, and I want to welcome you once again to class. Now we have a very interesting question to solve, and we want to find the values of x in this equation. It's an equation because what you have on the left hand side should be the same as what you have on the right hand side. So let's go right into the solution. On my left hand side, I have that x minus 3 to the power of x plus 2 is the same as x minus 3 to the power of x plus 8. What do I do to put a balance to this? Now, if I say x minus 3 to the power of x plus 2, I want to move this to this side, from the right hand side to the left hand side. So I'm going to say minus x minus 3 all to the power of x plus 8. And I'm going to say equal to 0. Now, going from the laws of indices, if I have x to the power of 6 is the same thing as x to the power of what? I can break this 6 down into 2 plus 4 or 3 plus 3, right? If I have something like x to the power of 8, I can break it down to be x to the power of 2 plus 6. Because if I add 2 to 6, I'm still going to get back 8. Good. So that's what I'm going to do here. And watch what I'm going to do to this 8. I'm going to say x minus 3 to the power of x plus 2 minus x minus 3. So this is x. Now plus 2, then let me add 6. So that if I open this bracket, I'm going to get back my x plus 8. Good. So I can further break this down using the laws of indices. If I have a to the power of m multiplied by a to the power of n, it means what? A to the power of what? M plus n. As long as the bases are the same, you can add up the powers under multiplication. So these two powers have been added using the same base carrying these powers, means that you can what? Decide to break down the what? The bases and share them among these two powers. So this becomes x minus 3, x plus 2 minus, then I'm going to do x minus 3 to the power of x plus 2, right? This is times, then x minus 3 to the power of 6. So what is the next stage? Remember, everything equal to 0, equal to 0. Then at this stage, I can factor out x minus 3 because I have x minus 3 here, x minus 3 here, x minus 3 here. So I can factor out x minus 3, as well as I have this as the power here. So x plus 2 out from this particular one. Therefore, if I factor out this, I'm going to have 1 here, then minus. Then what will I have here? Remember, I factored out this and this power from this particular point. So what I have left here is just x minus 3 to the power of 6, all equal to 0. Now, with what I have here, when you have two products multiplying themselves to give you 0, it means any of them is equal to 0. So from this stage, I have what? My x minus 3 to the power of x plus 2 multiply 1 minus x minus 3 to the power of 6 to be equals to 0. Since we have these two products here, so it means that x minus 3 to the power of x plus 2 equals to 0, or 1 minus x minus 3 to the power of 6 equals to 0. So if you go with the first one, that x minus 3 to the power of x plus 2 equals to 0, it is only possible in indices for a to the power of m to be 0 if a is 0. What do I mean? Take a to be 0, like I've said, a must be 0 for this base carrying this power to be 0. Let me say I have 0 to the power of any number, let us say 100. 0 means what? Nothing. Nothing to the power of 100 is still nothing. Nothing times nothing times nothing in 100 places is still nothing. Or even if it is 10 or 1 million, it still gives us nothing. So, knowing to that principle, I am going to say that this x minus 3, right, is equal to 0. That means x minus 3 here is equal to 0. So from there, therefore, my x, if 3 comes here, equals to 3. So that is one of the solutions. One of the solutions is x is equal to 3. Good. Then, from this other equation that I have created here, I can open this bracket like this, open the bracket, and all I will just do is to move this here. So it becomes 1 is equals to what? X minus 3 to the power of 6. Now, to eliminate this power of 6, I will multiply by 1 over 6. The power by 1 over 6. The power here by 1 over 6. So 6 will cancel 6. So what do I have? I have my x minus 3 to be equal to what? 1 to the power of 1 over 6. And what does 1 to the power of 1 over 6 means? It is not 1, as it were, because 1 to the power of 1 over 6 means that whatever, when you have a base carrying a fraction, what it simply means is that the denominator of that fraction becomes the root of that fraction, and the numerator becomes the power of that fraction. So what do I mean? It means that this becomes the sixth root of 1 carrying a power of 1. The sixth root of 1 carrying this 1 as its power. So sixth root of 1 means, what will I multiply 6 times to give me 1? It is still 1. And 1 raised to the power 1 is still what? 1. So because this is a root, I am going to put a plus or a minus there. So this becomes x minus 3 equals to plus or minus 1. So by the time I move 3 here, such that my x will now become 3 plus 1, which is 4, or x becomes 3 minus, remember there's a minus there, minus 1 equals to 2. So therefore, my values for x are now what? Either 3 or 4 or 2. So these are the 3 possible values for x, which we can try to insert in this equation to see if we are correct. Let us insert 2. So if we put 2 in this, 2 minus 3 becomes what? Minus 1. Then 2 plus 2 is what? 4 equals. Then 2 minus 3 is still minus 1. 2 plus 8 is what? 10. And this is an even number, meaning that if you multiply minus 1 4 times, you are going to get a positive 1. This is an even number as well. If you multiply minus 1 10 times, you are going to get positive 1. Good. Then let us also try 4. 4 minus 3 will give you positive 1. 4 plus 2 will give you what? 6. 4 minus 3 will give you positive 1. Then 4 plus 8 will give you 12. 1 to the power of any number is still 1, equal to 1. Then let's try the last number, which is 3. 3 minus 3 will give you 0. 3 plus 2 will give you what? 5. Then 3 minus 3 will give you what? 0. Then 3 plus this will give you what? 11. Remember, I told us that any number that is 0 to the power of any number becomes what? 0, irrespective of the power. 0 equal to 0. All right. Now you can see that either 3, 4, or 2 keeps our equation balanced.